going to show you a way to solve systems of equations in 3 variables using the TI-84 calculator. And of course this technique will work just fine for 2 equations and 2 variables as well. But since solving 3 equations and 3 variables requires a little bit more, I'm going to show that first. Now we already have our system of equations up here, and it is 3a minus 3b plus 4c equaling negative 1, and a minus 2b plus 2c equaling 2, 2a minus 2b minus c equaling 3. And we're going to use the calculator matrices to do this problem first. So we'll go to the TI calculator. We will hit second function followed by matrix to get into the matrix menu. Go over to edit and hit number 1 because I'm going to put everything in matrix A. Now it starts off by default as a 1 by 1 matrix, which means 1 row, 1 column, only 1 entry. Since I have 3 equations, 1, 2, 3 equations, and 1, 2, 3 variables plus a row of constants, I need to tell the calculator to give me 3 rows followed by 4 columns. And it'll give me the 12 zeros that I need. Of course, only 9 of them are visible. The other 3 are over here off the screen, but we will be able to see them shortly. Now, I'm going to go ahead and start putting in coefficients. It was a 3a, so I put in a 3, hit enter. A negative 3b, so I put in the negative 3, hit enter. A 4c, so I put in the 4 and hit enter. And then it jumps me over to the column where I can put in my first constant, which was a negative 1. And then the same thing for the next row. A 1a, a negative 2 for b, a positive 2 for c, a positive 2 for the constant, and now for the last row. 2 for a, negative 2 for b, negative 1 for c, and a 3 for the constant. Now my entire matrix is on the calculator, and to get out of the matrix editor, I'm going to hit second and quit. Now, at this point, I'm ready to find an actual solution. So I'll hit second and matrix again. Now you can see the A's got something in it. I go over to math, and I'm going to have to scroll down a little ways because what I want to find is something called the reduced row echelon form. The RREF is the command that I use. So I'll hit enter. I've got the RREF command up on my screen. And then I hit second function, matrix again, and under names, I hit number 1 because that's where I put it. Close my parenthesis, and when I hit enter, it shows me a matrix with diagonal 1s, but more importantly, the column on the right hand side has become a negative 2, a negative 3, and a negative 1. This literally means that 1a, or a itself, equals negative 2, b equals negative 3, and c equals negative 1. So my solution set is negative 2, negative 3, and negative 1, with, frankly, very little pencil and paper type work. And what's really nice about this is you can work with this with smaller matrices, therefore smaller systems of equations as well. Let's look at another example. If we had an x minus 2y equaling negative 3, a 3x plus 2y equaling 7, and a 2x minus 4y plus z equaling negative 6. This is still a system with 3 equations and 3 unknowns. It just so happens in the first 2 equations there's a variable missing, but that's not a problem. Go back to the calculator, clear out what we've got, go back to the matrix menu, go back to edit, put it back in matrix A again. We still need a 3 by 4. But remember, since some things were missing, we're going to have to put zeros in the right place. It was a 1x, a negative 2 for y. Remember, the z was missing, so we have to remember to put in a 0. And it was all equal to negative 3. Then we go to the next row. It was a 3 for x, a 2 for y. Again, the z was missing, so we put in a 0. And a 7 was the constant. And ready for the last row. 2 was the x coefficient. Negative 4 was the y coefficient. And this time the z was there, and there was one of them. And the constant was a negative 6. So once again, the matrix is in. So I will quit, back to the home screen, and I'm ready to solve. And again, here are the steps. Second function, matrix, go over to math, go down until you find the reduced row echelon form command, then hit enter, then hit second, matrix, and under names you put in matrix A, and this time when you hit enter, again notice it gives you the diagonal, and a 1, a 2, and a 0. So that means my solution set is 1 for x, 2 for y, and 0 for z. What's really nice about the reduced row echelon form is it can show you inconsistent and dependent systems. Let's say we had a 5a minus 4b plus 2c equaling 5, a negative 5a plus a 4b minus a 2c equaling negative 5, and a negative 7a minus a 4b plus c equaling 7. Now let's go put this one in the calculator. Second function, matrix, back over to edit. Whoops. Again, second function, matrix, over to edit, hit enter. Still need a 3 by 4. If this was a system of 2 equations with 2 unknowns, I would say a 2 by 3, but this one's a 3 by 4. Typing over, that was a 5 coefficient on A, a negative 4 coefficient on B, a 2 coefficient on C, and a 5 for the constant. All right. Again, next row, negative 5 for A, 4 for B, negative 2 for C, and negative 5 for the constant. Last row, negative 7 for A, negative 4 for B, 1 for C, and 7 was the constant. All right, again, quit back to the home screen. Going to go second function, matrix, under math, go down until I find the reduced row echelon form, hit enter. And then second function, matrix, and under names, A is where I put it. Close the parentheses, and this time we see something a little bit different. Instead of 1s on the diagonal all the way down, I go down and I see a 0, 0, 0. And if you scroll over a little bit to the right, it's the bottom row is nothing but a row of zeros. This is equivalent to the statement 0 equals 0. And actually, you might be able to see this better. You can actually hit math, fraction, and turn that matrix answer into a fraction, and it becomes a little bit more visible. Again, a row of zeros implies the statement 0 equals 0, meaning dependent system. If you had a system that was inconsistent, the upper rows wouldn't really matter. It would be the bottom row. You would get a 0, 0, 0, followed by a 1, which implies 0 equals 1. And that would be your inconsistent system, just like we've seen before. So this is a dependent system, and we didn't have to do anything with pencil and paper to figure this out.